Hi ladies, this is geometry. It's 3.1 to 3.3 quiz review, so this is the worksheet that you got in class today. So I'm just going to go over the solutions because sometimes it's kind of hard to just look at the key, so we'll go through it step by step in this video. So the first one, it asks you to construct segment EF, where EF is 1/2 of AB plus CD. So there's a couple different ways you can do this. You can either distribute this out so that you get EF equals 1/2 AB plus 1/2 CD, or you can do construct AB plus CD first and then just take half of that. I'm going to do it without distributing, and then I'll do it again with distributing. So the first one, we're going to use our compass, and we're going to use our compass to duplicate segment CD and just add that to AB. So actually first what I probably would do was use my straight edge to extend this line, and then I'll pick some point on there that is congruent to CD. So first you want to extend your segment AB so that CD can actually fit on that segment. And then you're going to go right from B and then add that segment CD. So AB is AB, and then B, and I'm just going to call this new point. I'll just call it G for now. But this new point G, BG is congruent to CD. Okay, so this whole thing, AG, that is the sum of AB plus CD. Okay, now the next step is to find half of that. So we're going to find the midpoint. So to find the midpoint, I'm going to construct a perpendicular bisector. So I'm going to make my compass pretty wide. And actually I'm going to start over here, but you're going to have to make 2 points because you need 2 points to form a perpendicular bisector. Okay, so I'm going to do that. Any point that's equidistant from my endpoints is on my perpendicular bisector. And doesn't really matter if you work above or below the segment. So here's 1 point on my perpendicular bisector. That's not enough. I need 2 points. So now I can change the setting of my compass and find my second point. And I'm measuring from my endpoints, finding 2 points on my perpendicular bisector. So again, it's not enough to just have 1 point on a perpendicular bisector. You can't just estimate and assume that it's perpendicular. You need actually 2 points. All right, so here's my 2 points. I connected those. Now this segment here is my perpendicular bisector to AG. That means this point, and I'm just going to label this H. That means this point H right here is the midpoint. So AH is half of AB plus CD. So now I'm going to take my compass, and I'm going to use my compass to measure this. Between H and A. And then I'm going to construct without changing my settings. I'll change my pen color though. so you can see. I'm going to make an arc from point E, that is the distance AH, and that point right here, it says construct segment EF, so this point right here is F. So if I'll make this colored. So it's coming from E to F, and that segment is the same as 1/2 AB plus CD. Okay, the next problem is duplicating angle B. So when we duplicate an angle, again, we're using our compass. We're not going to use our protractor to actually measure our angle, but we're going to use our compass. We're going to start at B and just some random arc. Doesn't matter how big or small it is, but it has to start at B. And then without changing your settings, you're going to move on to that ray, and you're going to do the same thing. Just make an arc. Now this arc at angle B has to intersect with both of those rays that form angle B. Okay, and then your next step is to actually measure the arc. So how big is it between where the arc intersects with this ray and when the arc intersects with this ray? Okay, so here's my point of intersection right here. Make it just my arc a little bit bigger. All right, so here's my point where those two intersect to form that next point in order to make the angle. Without changing my settings, I'm going to move it over here, and I'm going to do the same thing. I'm going to start where that arc intersected with ray B, and I'm going to use however big I measured angle B to be, however big that arc was, and I'm going to keep my settings the same and do it on ray B. So now I have a point that's on my second ray, and I'm going to use my straight edge to connect B to that point. And then if you use your protractor, those two angle measures should be the same. You can use your protractor to double check, but you cannot use your protractor to duplicate. So that's just a way to double check. On your quiz, you will not have a protractor, so you cannot double check. You need to follow the steps or create your steps to duplicate that angle. All right, the next one is constructing altitude BD. Altitude is a perpendicular segment from a vertex to the opposite side. Okay, so it says altitude BD. That means it has to come from vertex B. Okay, so we're looking for a perpendicular line that comes from here to AC somewhere. And I can't just draw a line and say, oh, it looks perpendicular. We need to actually construct a perpendicular line. Okay, so this point B is on our perpendicular bisector of C and some other point. Okay, so this is 3.1 where we had a line and we needed to find the endpoints, and then we constructed the perpendicular bisector. So we're going to measure how big is it from B to C, and then we want another point that's the same distance away from B as C is from B. So we're going to use our compass, and now we have this point, and it's not point D, but let's call it F. So B is the same distance away from F as B is from C. Okay, so now we have a segment, CF, and we want to create a perpendicular bisector. We already have one point on that perpendicular bisector, that's B. And we know it's on the perpendicular bisector because it's equidistant from the endpoints. So now we need another point. So to do that, we're working with the endpoints. So we can change our compass settings. And we want any point, and actually that's a little too close. I gotta change my compass settings, but maybe about here. So we're working from the endpoints, and we want a point that's equidistant from C and F. Okay, so right here, well, actually I just made 2 points, but that's all right. Right here is a point that's equidistant from F and C, and B is also equidistant from F and C, and so is this other point, but I don't really need a third point. So now I can use my straight edge to connect B and that other point to make my perpendicular bisector. Now my altitude, remember, is only, it's going to be on that and that opposite side. So you can go further, but make sure that when you label D, you label D right here on the opposite side. So this is point D. All right, the next question, we're constructing a median. Median is a segment from the vertex to the midpoint of the opposite side. Okay, so with that in mind, GH, we need to construct the median. So it comes from the vertex to the midpoint of the opposite side. So I need to find midpoint of EF. So I'm going to use my compass. And I'm gonna, just like I did in the very first problem, construct a perpendicular bisector. So I'm gonna start at E, and now I need 2 points on this perpendicular bisector that I'm gonna construct in order to find the midpoint. So points on my perpendicular bisector are equidistant from my endpoints. Oops, so it's not quite long enough. I need to go back and extend my arc a little bit. Whoops. I'm just gonna, let me start over for this one. All right, so here's my first point. And then I'm going to change my compass settings. And actually I'm going to make them a little bit bigger. Change my color so that you can see. All right, and there's my second point. So this is my perpendicular bisector that I just made. I'll do blue. Okay, and I'm going to label my M point just M, or my midpoint, sorry. I'm going to label my midpoint M. So this is the midpoint of EF. And my median is a segment from the vertex to the midpoint. So now I'm just going to connect those two. So GM is my median. Okay, number 5, use a compass and a straight edge to construct an isosceles triangle with two sides congruent to AB and base congruent to CD. Okay, first thing I'm going to do is just draw a base. And now I have to construct something congruent to CD. So I can make one of these. My base probably really does not need to be this long, but I can make one of these endpoint C and the other one D. So I'm going to use my compass. I'm going to measure CD because that's how big I want my base to be. So I'm going to duplicate CD onto that orange line that I just drew. Okay, so this endpoint here is going to be C, and then this is D. Okay, so this base now is congruent to CD. Now I need to get something, two segments that are congruent to AB. So I'm going to measure AB, and it's just about the width of my compass. Okay, now I want to use this twice. Okay, so I'm going to start here at my endpoint, and every point on this arc, oops, every point on this arc from this endpoint right here, from this endpoint, every point on that arc is equidistant, is the same distance as it is from A to B. Now I'm going to do the same thing, but from my other endpoint. So now every distance on this arc is the same distance from this endpoint as it is from A to B. Now wherever those two lines are intersecting, that's going to be the top of my triangle. So now I can use my straight edge to connect my endpoint here, and do the same thing again. Connect my endpoint here, here. So these two are congruent. They are both the same distance as AB, and the base is a duplicate segment of CD. Okay, and then the last one, it says complete each statement as fully as possible. Use my highlighter for this one so that you can see. Okay, so L, this point is on a perpendicular bisector. So whatever segment that bisector bisects is the endpoints of that segment are equidistant from L. So since L is on a perpendicular bisector, it's equidistant from the segment that that bisector bisects. So L is on this perpendicular bisector, which bisects AB. So L is equidistant from A and B. Not segment AB, it's equidistant from point A and point B. All right, the second one is M. M is on two bisectors. It's on this bisector, that bisects BC, and it's on this bisector that bisects AB. So M is actually equidistant from A and B and C, which means it's equidistant from A, B, and C. All right, the next one, N is equidistant from what? So let's find N. N is on two bisectors. It's on that first one that bisects CD and the second one that bisects AB. So N is equidistant from A and B and also equidistant from C and D. But it's not equidistant from B and C. It's not equidistant from B and C because it's not on that bisector. So since it's not on this bisector like M was, it's not equidistant from B and C, but it's equidistant from A and B and also C and D. All right, and then the last one, O is equidistant from, it's on two bisectors again. So O is equidistant from ED, and also O is equidistant from A and B, because it's on both of those perpendicular bisectors. Okay, so please see me if you have any questions and jot down any notes or make any corrections that you need to your review sheet. Thanks, ladies.